All right, we're going to jump to lesson, or actually to module 9 today. And module 9 is about right triangles and trigonometry. We'll still deal with some of the concepts of similar triangles that we've had, but we're going to start looking more at specifically right triangles and some things that we can do with those. We're going to begin by looking at the first lesson, which is on geometric mean. Okay, geometric mean is defined as if we have two positive numbers, A and B. X is the geometric mean. And what that shows is the ratio of A to X is equal to X to B. So geometric mean really means if we do cross products here of this proportion, X squared equals A times B, or X, which is a geometric mean, is equal to the square root of A times B. And this is really what we're going to focus on right here. The geometric mean for two numbers is going to be the square root of the product of those numbers. Again, that's going to be our focus. So you may start out with simple questions like this. What's the geometric mean between 5 and 45? Well, the geometric mean would be the square root of the product of those numbers. This case would be the square root of 225, and the square root of 225 is 15. So the geometric mean of 5 and 45 is 15. Find the geometric mean between 12 and 15. Again, our definition of geometric mean is it is the square root of the product of the numbers. So it's the square root of 12 times 15. 12 times 15 is 180. The square root of 180 is not a perfect square number like 225 was. So we can break it down and write it as 6 times the square root of 5. If you remember, what we do with 180 is break it down into product of primes, and then any base we can write to a second power to match that index comes out here, and that's how we get our 6 square root of 5. Now, why are we talking about geometric mean? Where does the definition come from? Well, geometric mean can be applied to parts of a right triangle. All right, and if we take a right triangle and we draw an altitude from the vertex of that right triangle down to the hypotenuse of the triangle, it's going to create two more additional right triangles inside that first original right triangle. Now remember, an altitude is a line that connects a vertex to the side opposite on a 90-degree angle. These three right triangles are going to be created, and I'll just put a drawing up here. These three right triangles created all have a special relationship. So let's step back to this. Here's my original triangle ABC. I'm going to draw an altitude CD. So I'm going to draw the altitude from the right angle down to the opposite side, and the altitude means we connect the vertex to the opposite side on a right angle. So what happens now is this altitude has divided my original right triangle into two others, this CDB right triangle and this CDA right triangle. And now these three right triangles, the two that we just created plus the original, they all have a special relationship, and geometric mean is part of that. All right, so we can use geometric mean to find some lengths of the sides of this triangle given this altitude, as long as we know some information. The first geometric mean theorem we're going to deal with is how we can find the altitude. So this H length right here, okay? This pretty much says the same thing that I said above. The altitude drawn from the hypotenuse, or excuse me, from the right angle to the hypotenuse in a right triangle will divide this original hypotenuse, right? Hypotenuse is the side of the triangle across from the right angle. So AB is the hypotenuse. So this altitude is dividing this hypotenuse now into two different lengths, X and Y. And what studies show is that this altitude is the geometric mean of the product of the two segments it gets divided into. So this H, the height here, the distance of CD or the length of CD, is equal to the square root of the product of X and Y. That's geometric mean. So given this drawing, I know H is equal to the square root of X times Y. Again, X is the distance from A to D, Y is the distance of D to B, and that's what we've divided this altitude into when I dropped in this hypotenuse into when I dropped in this altitude. So one thing we can use geometric mean for is to find altitude. A second thing we can use geometric mean for is to find leg lengths. Now, let's talk real quick. If I have right triangle ABC, AB is the hypotenuse, C to A and C to B are the legs. So we're talking now about finding the length of C to B or C to A using this concept of geometric mean. And what the description says is the length of a leg of a triangle is the geometric mean between the length of the hypotenuse and the segment of the hypotenuse adjacent to the leg. So let's talk about that. Okay. If I want to find the length of B, this leg of the original right triangle, then I know B is going to be the geometric mean of the distance from A to B, which is the hypotenuse of the original triangle, which is C, and the segment of the hypotenuse that is adjacent to the side I'm looking for. So X is the piece of this hypotenuse that's adjacent to the side I'm looking for. Adjacent means they're connected. So I know to find the length of B is the geometric mean of X times C. To find the length of A, this leg of my right triangle, that's going to be the geometric mean of Y times C. So it's the square root of Y times C. So we can use this concept of geometric mean to find missing side lengths of the legs of a right triangle, or on the previous page, we found the altitude of the right triangle. Okay, so putting that all together, let's say we were given this diagram and we're asked to find X, Y, and Z. So you can see ABC is my original right triangle. We've drawn in altitude BD. We've drawn it from the right angle to the AC side, which is the hypotenuse. And AD divides the hypotenuse into segments of 8 and 25. So the full length across is 33. But A to D is 8, D to C is 25. They're asking us to find X, Y, and Z. Well, to find X, X is a leg of my right triangle. And because it's a leg, I know that I'm going to find the geometric mean of the segment that's adjacent to X, which is 8, and the overall hypotenuse, which is 33. So the length of X is a geometric mean of AD, which is 8, times AC, which is 33. So how do we find geometric mean? It's the square root of the product. Square root of 264. If you simplify it, it's 2 times the square root of 66. That's about 16.2. So that distance is about 16.2. Okay. How do we find Y? Well, Y is a leg also. And to find the leg of a right triangle using this concept, it's going to be the geometric mean of the segment that's adjacent to Y times the overall length of the hypotenuse. So it's going to be the geometric mean of DC times AC. So 25, which is DC, times 33, which is AC, is the square root of 825. That's 5 square root of 33, which is about 28.7. So this distance is about 28.7, this distance of Y. Now finding Z. Z is the altitude. And that's the first one that we learned today. So the altitude is going to be the geometric mean of these two segments that it creates out of this hypotenuse. So the altitude Z is going to be equal to AD times DC. So that's the square root of 8 times 25, the square root of 200, 10 square root of 2, or about 14.1. So this distance is about 14.1. All right, so that's using geometric mean in right triangles. All right, and you'll be asked tonight to find these different lengths using this concept of geometric mean. So review these notes as you need to, have them handy. Make sure you refer back to it and look things over to help you as you move along. But your assignment is going to be on the McGraw-Hill site. So make sure you get to the McGraw-Hill site and get the work done for tonight. All right, we'll talk to you later.